Hello, my name is Alex Gonzalez, and this is the part 2 of the problem that I presented about how to find duplicates from an unsorted array. What I want to do is to make this a little bit more interesting by saving the indexes of the duplicated values. And so as you can see, there I have already a bunch of code over here that I might not reuse all of it, but I'm gonna try to reuse whenever possible. So basically, we have an array of 10 elements in this case, and this array it's found and reported what are its duplicates. But what I want to do is as well find what is the position and save it in a way that I can dynamically access it. Because if this is a 10 elements array, but what if it's a 1,000 elements in the array or so? Probably you shouldn't use an array, but it's an example. So cc duplicates, let's see, that show duplicates. What it does so far is that it generates an array with random numbers, and then it says that the number 3 is has duplicates, and the number 5 and the number 6. Number 7, as you can see, there is no duplicates for that, nor for 2, 9, and 1. And so what I'm going to do is, first of all, comment out this. I don't want more trash. Oh, wasn't it that the only one? That was the only one. I'm going to print list, print n2. Okay, printing it there maybe. Yeah. Yeah, so this is clean, right? This is the output that I'm looking for. And I want to show you what if you have 50 elements. You're gonna have something similar to this. So there is many elements that have a duplicate. 36, for example, has one here, and I don't know where else. But what if I want to see as well that where the 36 is located? So it has to tell me that it's in the position number 2, and this position, whatever that is, right? And I can see that 40 as well has a duplicate here and here. So I want to access those values in the array directly. So the way that I'm thinking to fix this is to create another array of lists, and the lists are going to have the access to the index of those duplicated numbers. Why am I doing this? Because somehow what I'm going to implement is a hash table, hash table on C using the simple linked list or single linked list over here. So what I want to do, first of all, I was using a struct for the values, and I'm going to now use a struct list that is going to be having the value as identifier, and then it's going to have a pointer to a struct node that it's going to be my head. It's going to be the head of the list. So here the value is going to have, for example, the number 36, and the elements of the list, each of them is going to have the index. So struct node int index, and it's going to be struct node next, and that's what I'm going to do. So basically my array let's call it catalog. Catalog? It's not a catalog. It's actually the master index. It's an array. Let's call it or name it it's not a list, it's an array, it's a collection. Yeah, collection, catalog. Okay, let's go with catalog. Now, the catalog might have up to elements as well. I mean, I can have lots of those elements in there that are gonna, I mean, if I have 100, then I'm gonna probably have 100, which is gonna create a huge array that is gonna be expensive. So what I want probably is not an array. What I want is a list. What happened here? It's a list of the elements of the array that are not duplicated. Oh, interesting. So pretty much I'm going to reuse some few of the functions that I already created. So I'm going to say struct list. Let's say master. It's going to be my pointer to things, but I usually don't like to have global variables. Let's move it in here. And we are name this as dupes index. I'm gonna send the array. I'm gonna start doing my code. So for equal to 0 in lower than LMs. And this is going to be pretty much similar to this. Similar, but not the same. But I'm going to copy the code because pretty much it's going to be something that I can see reusing for a lot. What happened? I didn't copy. Okay, so I'm not really probably going to use this one here. If counter is equal to 0, I'm not going to use a counter for J. And the LMs, I'm going to... I don't really need a J because I'm not going to parse it twice. I don't need to find the duplicates, I just need to add initialize, yeah. For every single element that I find, I'm going to add it. So, what I'm going to do, I'm going to copy in list because this is going to control a different type of structure, and I need my own structure for this purpose in list. This structure is what I mean. Okay. So if at node even, I need to copy but I'm gonna make a pause here because I don't know exactly how I'm gonna use that node yet, but just found it here. But actually it's at master node. Because at master node, not in the list. I don't care if it is not in the list, or do I care? I don't care, actually. I'm just gonna add it to the master because every single element has to have an index there. So for all these things, I'm gonna add to the master master list. The array I element. Yeah. Okay, so master node, I don't need in list. Just go and put it there. So I'm sending the node. Actually, no, I'm sending the list, and I'm sending the value that's gonna be added. But I don't need only the value, I need as well the position, because that's what I'm interested in, the position. So int I position index position. I'm gonna say position. Okay, so sure, I'm gonna need a node, but first I'm talking about a master node. So I need to parse the master head to see if it already exists. Master list, well, head to be, if master head is equal to null, then is equal to struct. I'm not going to add another element. Here, I'm going to add it here. New master node equal to malloc size of struct list, and then new master node head equal to null, and new master node val equal to val. Then master head is equal to new master head. Now, I need to add the index node into the list master head that I'm working with. Now, if it's not null, well, I'm pretty much doing the same, right? Anyway, if it's not null, then, well, actually, this comes the I don't need to create another master node. If it's not null, I'm gonna find val in master. So I'm gonna send the and the val. And actually, I'm gonna need the I'm gonna find the value through and once I find it, add index master index into now internally in add index I'm gonna create for No, this is not the master header. This is now, well, actually this is the master head. But now struct node. If I am looking into the master head, there I have the pointer to the head of the list. Well, master and list should be the same. Yeah, I want to change this to not be confused. I can do just search, but anyway, I'm there. Okay. So I'm gonna add the index at 2. One is the master list and the other one is the, let's say, child. So here we know where is the head, struct node, and I need to create a new node, pointer, that is going to be equal to and new node equals to next to null, new node. I named it, let's see, index. I'm gonna say position to be I'm gonna say position and it's position. So I have my new node, and similar to here, child only. If head, no, not that head. Yeah. List head is equal to null. Then the head is equal to new node. Else for struct node asterisk index equals to list head and index not equal and index subfield next not equal to null, then index equals to index next. Sorry for that long loop. I'm moving with this the index to the last element, which means that index subfield next equals to node, and that's it for the add child. Yeah, this is gonna be my head, this is gonna be my new node. I'm just putting it in the right position, in the right place, in the position. I have already the position. And here I already have I need to add something at the child if the master list already exists. Let me see if there is any master. Master node. Okay, the master list. Okay, so I'm looking here at master node, then malloc at least here. I don't know. I want to add the child no matter what, but I'm not always gonna add master node here. So find list for this val. Strict list. Yeah. So this is going to be my index actually, because I'm going to move this. So for index not equal to null, index equals to index. Oh, I'm finding it. Yeah. But I need to send it back. I'm gonna do it this way. Struct list. some point, I don't know when, I'm gonna return. Actually, yeah. So I'm gonna parse the index to find the val. Index val equals to val. Then and then and that's it. But what happens if it's not found? It's not found, its index is going to be null. But we are not expecting this to be null. Or are we? If list index is equal to null, then we need to create is equal to it's equal then I'm gonna put this new node into the end of the list of list head. To do that, oops. I'm going to use another index and I'm gonna pass L index. I'm gonna move it to the end of the list index. Once I moved it, index next equals to new list node, and then I have it. So I have to say that list index is equal to new list node. My index is going to point to the new list node, which is this, and then this element is going to add a child. All right. I'm not explaining that a lot because I was more concentrated in the coding of these two lists that I'm playing with: the master list, or the list, and the child list. So following these, I'm gonna copy paste this. The index is there. Yeah, it's not there. Well, then a child is not either there. Is there any other? All list, find list. It's gonna be interesting to debug. Okay, so I'm gonna do a second review. I'm gonna get the index of the duplicates, and I want to send the array. I'm gonna parse from a master list that is null, that is a list. I'm gonna parse all the elements, and I'm gonna add the master node to those elements, but I'm gonna pass the array value and the position. So the first add master node, it's gonna add the master list, which is the main list, and I'm gonna have a pointer to the list, and if it's null, then what I'm gonna do is create a new node and then initialize the master list, and then add a child based on the position to the list. And I said I'm sending here I, but I don't need to send I need to send the position. That's the add child. Okay, I'm gonna, now the list head, Yeah, this is gonna be my first element, but list head, it's now this list. But I don't need to send the list head, I need to send the list head. Let me see a child. Yeah, I need to send the head. Which at this time, at the very first time, this is going to be null, and the position is going to be added. So let's take a look to this. So child, it's list head. I'm creating a new node. I'm adding the position and the null, and if it's null, then I'm going to add a new node to the list head that I just created. And if it's not null, then I'm going to create a node. I'm going to move to the end of the list head. Okay, so I need this outside. If not, I'm not going to be able to do anything. And then I'm going to move my index into the next element. I mean, the pointer of the next element is going to be the new node. And the new node is what I created here, which is fine. So a child should work. Now, what if the add master node doesn't have yet? It's not null. If it's not null, I'm going to need an index to parse it. And I want to see if I can find already the value into the list head. And I'm sending the index because if it's found, if it is found, then I'm going to add the index head into the here. But it's not if it's found. Let's see the find list. Find list. It's gonna, well, I set it up to return this, but I'm not doing it because I'm passing it by address instead. So list, having an index, which is the head, and if it's not null, then we're going to do something. But if it's null, then it's going to pass this, and the first time it's going to be null, and the list index is going to be null, so it's not going to be found. And if it's not found, because it's null, then I'm going to create a new one. Okay, sure. But if it's not equal to null, if there is anything there already there, we're going to see this is the master list. I'm going to, this is the master list. So I'm going to look for the value that is equal to the value, and then I'm going to return the index that is moving, and this is going to be the place where I want to get the head from, which is this. But if it's null because it was not found, means that I need to create a new list from a structure. The head is going to be null, the value is going to be val, and I want to parse the index till the last element and add to the new list. because this is supposed to be the second element at least. And then this is the position of the last element, and then I'm gonna say that the list index that was found or created was the new list node. And that's where I want to add it. So it seems like it could work. But okay, let's see where I'm gonna add. Let's see the errors first. Well. Okay. 43. Well, okay. Okay. New list head 75. Oh. New list node. This head 76. This is gonna be a tricky one. Maybe. 76. Request for memory heading something not in a structure or union. I guess I'm gonna send the address of this thing. The address of this, that's what I want to send. List head is a pointer. Do you mean to be used? Uh-huh. Passing an incompatible pointer. I hope this could work. Struct list and a struct node. Oh. I'm passing a struct list and not child. Struct node. Here's struct node, which has to be changed as well. LightX on declare. Track list has number next. 88. It's not. No. Because you have the it needs some elements next as well. Because first I was thinking about having only one. Having only one array, but now no. So I need to initialize. Initialize it to null. Okay. I on declare 96. Oh, it's not ice position. Keep doing that. In there. Find list, conflicting struct. Okay, find list. I thought I did it, but I apparently didn't. Okay, I'm gonna do a quick bio break. Hold on. Right, I'm back. 2024, just 1 minute. Okay, so segmentation pool, why not? Oh, sure. I think I'm not. Okay, it was not a segmentation pool. I'm very, very happy, surprised. But I haven't parsed. Haven't parsed any of these guys. So print indexes. I want to send the list head, which is the master one. Indexed. Print index, just like that. Okay, so I'm gonna add a couple of indexes. And I'm gonna print for list index not equal to null, index then I'm gonna do printf list and I'm gonna print the val, and if print if list index subfield head is not equal to null, I'm gonna an index list, and index is equal to list index subfield head, and similarly for index equal to null and index is equal to an index next printf, and I'm gonna add some space here to say node position. Index subfield position, and that's it. I'm gonna print the index and the subindexes. Let's see. Here 7. Compatible pointer strict list. Oh, I said list, here is node. Because I'm parsing now the nodes. Yeah. That's it. Okay. Now I have 100 elements here, but I don't want that many. 50. Let's start with 10. Ta-da! Index position 0, 3. Position 0, 3. 3 is in position 0 and position 4. 0, 1, 2, 3, 4. It works. So 5 is in position 3 and position 5. 5, position 3 and position 5. So I'm printing many times the list. Because it's into the loop. Print index here. Okay. Let's printing at master node. It's in the 4. So it's print index. Oh, it has to be, yeah. Yeah. So the 3 is in the 0 and the 4. Yeah, the 6 in the 1 and 6. 1 and 6. Yeah. 7 in 2. In only position 2. That's fine. 5 is in 0, 1, 2, 3. Yeah, we reviewed that. 2 in numbers in position 7. Yeah. 0, 1, 2, 3, 4, 5, 6, 7. Yeah. 9 in 8, yep, and 1 in 9. Perfecto. Whoa. Okay. So in this way you can have the positions in an array, and if you want to parse over the list in an easy way to find the position in a huge array, then you can have some sort of a hash table. And just to confirm that this works for a larger number, let's go back to 50. Yep. Well, it looks like it works. I mean, I don't see why not. Yeah, there's too many numbers. 29, 23. 29 or here. 29, close to maybe 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So 29. Yeah, it's 40. So it works. Thank you so much for watching, and any questions, you can find me at KOZLEX in Twitter, Coslex. Thank you.